everyone. I'm Rajasri, Assistant Professor, Department of EEE, working at MLR Institute of Technology, Hyderabad. And in today's lecture, we will be checking three-phase full converter with RL load. And I've already explained in detail how to draw these phase voltage waveforms, line voltage waveforms. I have already explained the phasor diagram as well. And if you need that, you can go through the previous videos. And now, let us check out the output voltage waveform for alpha is equal to 60 degrees. This is output voltage waveform for alpha is equal to 60 degrees. So here, this is a zero crossing. And as I told you, this is full converter. All the devices which we are making use of in the circuit will be fully controlled devices. So that is the only reason here we are making use of thyristors. And here, this is a zero crossing. Alpha is equal to 30, alpha is equal to 60. So we have decided to trigger the thyristor at this instant called alpha is equal to 60. Only then it conducts, or otherwise it remains in forward blocking state. That is forward blocking state in the sense ready to conduct but not at conducting state. So that is the reason the moment when we provide the triggering pulse, only thyristor starts conducting, otherwise no. So here we have provided the triggering pulse at alpha is equal to 60. And how long it conducts till R5 phase ends. So this is your output voltage waveform for alpha is equal to 60 degrees. That is, it is conducting right from pi by 6 plus alpha to pi by 2 plus alpha. Pi by 6 in the sense 180 by 6, 30 degrees. And it is conducting, as I told you, pair of thyristors in full converter will be conducting for a period of 60 degrees. Pair of SERs will be conducted for a period of 60 degrees. And each thyristor in a full converter will be conducting for a period of 120 degrees. So that is the reason here it is conducting from pi by 6 plus alpha to pi by 2 plus alpha plus 60 degrees. And this is RY phase. This is R phase and this is Y phase and this is B phase. So since RY phase is active, thyristor 1 is conducting current through the load and then T6 and back to load. So here RY phase 6 and thyristor 1 are conducting. As I told you, the sequence, see here 6 1 1 2 2 3 3 4 4 5 5 6 and 6 1 cycle repeats. So this is what the interval. This is the first interval, second, third, fourth, fifth and sixth interval, and again first interval repeats. So this is the sequence how the devices will be actually conducting. So here RY phase, and because of RY phase, thyristor 1 as well as thyristor 6 were conducting, and the moment RB phase is being appeared. So this is your RB phase and this is a zero crossing, alpha is equal to 30, alpha is equal to 60. So here RB should conduct for so much period of time. So here RB will be conducting. RB in the sense, this is R phase load and again this is B phase, T2 will be conducting. So here 1 and 2 are conducting because RB is appeared across the load. And now see here Y phase is being appeared. This is a Y phase zero crossing and this is 60 degrees. So here YB phase is conducting, and when YB phase is applied, in that case see here Y, this is Y and Y will be applied across T3 load and back to supply. That means because of YB phase, T3 as well as 2 and 3 are conducting. So here 2 and 3 conducting, and again zero crossing at alpha is equal to 60 we have triggered, YR phase is conducting, and this is 3 4. YR in the sense Y and this is R is conducting. YR phase, and the cycle repeats. So this is your output voltage waveform for alpha is equal to 60 degrees, where output voltage remains remains continuous for alpha is equal to 60. And if you increase the firing angle beyond 60, in that case, output voltage may become discontinuous. And talking about the output current waveform, since the inductor, we have chosen inductor in the load, the value of the inductor is, see, initially when the thyristor is conducting, the polarities across the inductor will be positive, negative. That means inductor is actually charging, and by the moment inductor is completely charged, the voltage across the inductor will be VL is equal to L into di naught by dt. And this inductor, it tends to it does not allow any sudden changes in the current, so it tries to maintain the current flow through the load in the same direction. So that is the only reason, according to Lenz's law, it tends to reverse the polarities and it tries to maintain the devices into the conduction state. So that is how, though the output voltage is 0, output current will be continuous. And this output current continues and ripple free because of the very large value of the inductor which we have actually chosen. So this is nothing but our output current waveform. And now let us see the individual waveforms for current through R phase, Y phase and B phase. See, current through the R phase, that is as long as thyristor 1 is conducting. See here, R phase is actually connected to the thyristor 1. So as long as thyristor 1 is conducting, we will get current through the R phase. We need to indicate the current through the R phase. So here, current through R phase in the sense, right from pi by 6 plus alpha. This is 0 crossing pi by 6 plus alpha is equal to 60. And right from here, thyristor 1 is active. And how long thyristor 1 is active? As I told you, it will be conducting for a period of 120 degrees. Each thyristor will be conducting for a period of 120 degrees. So that is the reason pi by 6 plus alpha 2, it will be conducting till 5 pi by 6 plus alpha. And again, once the phase change, thyristor 1 will be reverse bias and now YB phase is appeared, and because of this YB phase, RYB, so YB phase in the sense thyristor 3 as well as 2. So now because of YR, here the supply current will be reversed. Supply current will be reversed because of YR phase. Let me explain you how. This is Y phase and this is R phase. So when Y phase is active, T3 will be active, conducting current through the load, and R phase, and if you see here, supply current will be like this. Supply current will be in the downwards direction, and in the previous case, supply current was in the upwards direction. So that is the reason here during YR phase, T3 as well as T4 are conducting, during which here the supply current will be negative. And again, when R phase appears, during which the supply current will be positive. And then IY phase. IY phase in the sense current through the Y phase. Current through the Y phase will be appearing during when Y phase is appeared across the load. So during which Y phase is appeared across the load, and again it is off, and again see BY phase and RY phase, during which Y phase will be negative, and again 0, and again when Y phase is conducting, we will get the positive current. And similarly B phase, IB phase, current through the B phase. See here, current through the B phase in the sense, whenever B phase is conducting, you will get negative RB and YB, during which the current will be negative. Why is it so? See here, RB and YB. This is R, Y, B. R in the sense thyristor 1 should be conducting, and B phase. B phase in the sense thyristor 2 is conducting. So during which it will remain negative, and again it remains 0, and again it remains positive. So this is a quasi square waveform which will be getting for phase currents. And similarly, let us check out the output voltage waveform for alpha is equal to 90 degrees. And if alpha is equal to 90 degrees, this is 0 crossing, alpha is equal to 30, 60, 90. Right from here to here, we will get the output voltage waveform. So if I represent the same, this is RY phase, which is appeared across the load. When RY is active, thyristor 1 as well as thyristor 6 are conducting. 6 and 1 are conducting. Similarly, it is getting turned off, and now RT in the sense this is 0 crossing 60, 90. So from here to here, we will be getting the output voltage waveform. And if you see, output voltage is remained 0 during this period. That is the reason I am saying for alpha is equal to 30 and 60, output waveform will be continuous. When alpha is greater than 60 degrees, when it is exceeded beyond 60 degrees, when it is equal to 90 degrees, the waveform will become discontinuous. It will be a discontinuous waveform. So this is three-phase full converter with RL load. And average output voltage expression is V naught average is equal to 1 by T, 0 to T, V naught of omega T, d omega T, where here time period is, I am writing the V naught average expression, that is 3 root 3 Vm by pi cos alpha. This is the V naught average expression for a three-phase full converter with RL. In the next lecture, we will be discussing dual converter. Thank you.